So let's spend a few minutes looking at a couple of examples of how to determine if a given molecule or ion is going to behave as a nucleophile or an electrophile. And sometimes it's not clear-cut, as we're going to see. So first of all, let's review the definition of nucleophile. A nucleophile is a Lewis base, and they donate electrons, so these need to be electron-rich. Electrophiles, this is another word for a Lewis acid. They accept electrons, so they're going to be electron deficient. And so some things that you want to look for when you're trying to assess what we call the nucleophilicity or electrophilicity of a given structure are the presence of a charge. Okay, so this could be plus or minus, because that's going to have different consequences. Lone pair electrons, multiple bonds, so pi electrons, and what we call heteroatoms. So these are atoms other than carbon and hydrogen. So these are other than C or H, because what we're really looking for are bond dipoles. Okay, so let's kind of take a look at ethanol here as an example. And one of the first things I notice is that ethanol has an oxygen present. And I know that oxygen is more electronegative than the carbon or the hydrogen that's on either side of it. So we have a dipole in this direction. And so we have this kind of partial charge density on the different atoms. And then we also see that there are lone pairs on the oxygen. None of these CC or CH bonds, if you remember from early on in the first few videos that we looked at, CH and CC bonds are not polar or not significantly polar. So really any reactivity, any difference in electron density is coming from this oxygen being present. And so right now I have evidence that this structure could be a nucleophile. My evidence is that I have an oxygen with lone pair electrons, and I also have an oxygen with a partially negative charge. However, on the flip side of that, I also have evidence that this structure maybe could behave as an electrophile, because I have a C and an H atom with a partially positive charge. So how do we answer the question, is it a nucleophile or electrophile? I hate to tell you, but the answer is it could be either one. And I know that makes students very uncomfortable, not being able to say with certainty which category something belongs in. However, this is very, very case dependent. There are going to be some reactions where you will put ethanol in the presence of a strong nucleophile, and ethanol will behave as the electrophile. Or you could put it in the presence of a strong electrophile and it will behave as the nucleophile. So don't worry about that too much. Just start looking for evidence of either areas where it could be nucleophilic or electrophilic, and we'll worry about the details of how it behaves in the chapters to come. Let's do the same type of analysis here. I'm noticing that I have an oxygen, again, with lone pairs. I have a dipole in this direction, so I have, once again, delta plus, delta minus, and I have pi electrons. Okay, so if I'm going to list my evidence, I'm going to say that it's nucleophilic, particularly at the oxygen, because the oxygen has lone pairs. And the oxygen is partially negative, excuse me. But then on the flip side of that, oh, and I forgot about pi electrons, which we saw can be basic. The flip side of that, we have potential electrophile because we have the delta plus carbon atom. And we will see cases, not in first semester, but in second semester, you will definitely see cases where sometimes this carbon can be electrophilic, and in other reactions it's the oxygen that's being nucleophilic. So it completely depends on the situation. Okay, and let's take a look at this one. I put a skeletal structure on here because I want you guys to get used to seeing skeletal structures more often. And what we have here is just carbon, 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 so 4 in a row, but there happens to be this double bond in between the two middle carbons. There's no evidence of any dipoles, certainly no significant dipoles, but we do have pi electrons. And so the only piece of evidence that I have right now is that this is going to behave as a nucleophile. So I'm going to put nucleophilic because there are pi electrons present. I don't really have any evidence of this molecule being able to behave like an electrophile. So this is the type of analysis that I want you to start doing, and as we go through various structures throughout the course, we're going to come back to this type of analysis and start looking at what regions of a molecule might be electron deficient and what regions might be electron rich, and that's going to determine how that molecule or ion will behave in a chemical reaction.